In this video, I'll be reviewing how to solve question from position and velocity graph worksheet. And so this is the one that involves Mr. Vogel pacing while creating assignments. And so you can refer back to the sheet to see the actual problem there. I've set up a couple graphs for us to use. One of these is going to be position versus time, and the other is going to be a velocity versus time. So I'll set this up now. This is going to be position versus time. The other will be velocity versus time. To get these going, one of the things that we've said to start with is by setting a scale. So we need to know what scale this is going to be on in order to solve it. The position in this is going to be pretty straightforward. The problem states that I'm just walking back in front of the whiteboard, so back and forth in front of the whiteboard, which we said is 5 meters long. If we assume that I start with position 0, as we often do, then that means that the furthest position away that I'm going to get is going to be 5 meters. And so we can start labeling this by marking off portions along the y-axis and so we can call to these 1 meter, which means that we should show that this position is shown in meters. The time is going to be a little bit more difficult and more complicated, and so we'll have to look at what the situation describes to make sure that we can trace it through. So I'll bring up another sheet for us to go through to address that. And so we'll start to keep track of what I did. So what the question says is that I took 6 seconds to walk aboard my first time. So we'll have that as 6 seconds. I walked across the full board, which is 5 meters, and then I walked back at the same rate. So because I have gone at the same speed here, and I'm going the same distance, still the same 5 meters, then we can assume that it's going to take the same amount of time, which we could also verify by calculations. So what this means is that up to this point, I've gone a total of 6 plus 6 seconds. I then wait at the other end for 5 seconds. So we'll tack that onto our time as well. The next part's going to be a little complicated. It says starts to walk back at half his original speed and stops in the center of the whiteboard. And then I'm also stopping for 5 seconds after that. So I'm going to leave a blank for the walking portion because we need to figure out what that is, and then add on that last 5 seconds to get our total time. In order to find the time for the center of the board, we're going to have to deal with the other information that we're given. Because this refers back to the rate that I'm going with, which is the speed, I'm going to need to know what speed I'm going at. This can be found based on the fact that I'm going at half the original speed, meaning we should find the original speed. We can find speed using the calculation speed equals distance over time. And in this case, it shouldn't be too complicated. We know that the distance to cross the board, so for my original speed, so if I write this as original speed, so that'll be 5 meters, the distance across the board, in a total of 6 seconds, which is going to give me about 0.83 meters per second. That'll give me the speed for that original time. I know that my new speed is half of this, so I can show that by taking 1/2 of 0.83 meters per second, which will give me about 0.42 meters per second with rounding. Working off of this speed, I can now try to figure out how long it's going to take me to get to the center of the board. This is going to be a little bit complicated because now I have to think about the same equation that I had before, the speed equals distance over time, but in this case I'm interested in finding the time. In order to do so, I'm going to have to take that equation and solve it for time. I can do so by multiplying both sides by time. So if I start with my original equation, speed equals distance over time. I multiply by time to get that out of the denominator. Since we want to solve for time, it can't be in the denominator, so we can multiply both sides of the equation by time, which will give me that time multiplied by speed is equal to distance. And then to isolate the portion that I want, which is the time, I need to get rid of speed by dividing both sides by speed. That will give me that time equals distance over speed. In this case, I know I'm going to the center of the board. If I start from one end and go halfway to the center of a 5-meter board, that's going to be a total of 2.5 meters. And my speed in this case is what we found over to the left, the new speed I'm going to the center of the board with, so that's 0.42 meters per second, which will give me a result of about 6 seconds. So if I put that back into the equation, the calculation I was doing originally, the one to find the total time, then this shows that I'm going to have 6 plus 6 plus 5 plus 6 plus 5 seconds for the total time span. It's a total of 28 seconds, which means that I will need to show as 28 seconds on the time axis of my graph, and it'll probably be a little easier just to take it up to 30. So let's return back to that graph now. We can mark off the time axis. I'm going to mark it off every 5 seconds. And so that'll be 5, 10, 15, 20, 25, and then 30 at the end, so that'll give us enough space. Now that we've labeled our axes and we'll note that the time is in seconds, we can start to put this together. The key that we know is that we have a lot of information to work with and we know a lot of key positions. So what we should do is to graph a lot of the key points, and then we can connect them with lines to show the overall shape of the graph. So let's start off with the first question. If I'm starting at the left side of the board and I have defined that as 0, then that's going to be starting at our origin. So 0.00. I'll then move up to a point that's 5 meters away. I know I've walked across the board once according to the problem, and that takes me a total of 6 seconds. What that means is I'll go along my time axis to about a little past the 5, and then go up to the 5 in the position axis, which will give me the point, whatever x coordinate comes first, 6, 5. It then takes me 6 seconds to return back to the other side we said, since I'm going at the same rate. And so that'll return me back to a position of 0. 6 seconds later we'll be at 12. And so we'll mark that as 12, 0. If I stay there for 5 seconds, so my position is not changing, that means I will still be at position 0. And time will now be 5 seconds later by the end of that, which will bring us up to 17 seconds. And so that brings us to the point 17, 0. Next comes my trip to the center of the board. And based on the calculations we did before, we find that that'll take 6 seconds, which brings us to a total time of 23 by adding 6 to the 17 we've done so far. And we also know that that's going to be bringing me to the center of the board, which is a position coordinate of 2.5. Which means that we'll have this point at 23, 2.5. And if I stay there for the last 5 seconds, then that will maintain the position at 2.5, and I will stay there until 28 seconds, meaning that I will have the point 28, 2.5 on there. So together we've got this new graph that we will show, connecting the lines, and I'll do it with a straight line tool to show what the position looks like as we go along here. it will end up looking something like this. For the overall shape of the graph. That will take us through the position graph of problem 1.